Hello, welcome to Micro. This is almost 5:15 p.m. and you are about 17 students. Enrollment is better than the morning students, really. In the morning when I start at 8 o'clock, there were 14 students. So we have a number of students, 41 in the evening and also 41 in the morning. Well, let me give you some information. If there is anything to explain you, I'll come at the end. We discussed last time before we have done a lab activity, we discussed on chapter 20. The chapter 20 topic was microbe relationship and epidemiology. So in another old version, it says infection and the disease. I gave you general idea on that. Okay, so when we say disease and infection, what infection is, what disease, we gave you a meaning already. You know it really. You are professional already. The relationship between the host and the microbe is infection. So the product is going to be pathologic effect. Clinically, you can see acute, subacute, chronic case during the process of infection. So if there is any state of change from normal condition to pathological process, that we call it a disease, you see. So disease is the product, the change which we are going to observe. We discussed that. And then when we are going to talk about the disease and infection, really, it is necessary to focus on bacterial area according to our syllabus, bacterial area. But last time, as introductory information, I gave you from parasitic origin, viral, fungal origin, and then bacterial. The most dominant character which we need to study about the epidemiology, pathologic effect, disease causing factors, virulence factors are coming in bacteriology. Yes? Okay. Now, bacteriology. That means the study of bacteria. You see, parasitology, mycology about fungus, virology about the virus. Those ones we avoid on this condition. Okay, we are going to focus on bacteria because we are going to study about disease. The disease being created, caused by virulence factor of those microorganisms we touch. That's why we are coming to understand about the antigen. Virulence factors are part of an antigen. Virulence factors are the enzymes in bacteria. So they are also the part of microorganism, and then they are appearing in the form of an antigen. These antigens are coming with a different molecular weight. We call the highest molecular weight antigens are more response and more virulent on causing a disease. That means higher kilodalton protein means measurement of the protein is high. The virulence factor causing a disease, it is one factor. And the other thing is also that bacteria, when it grow very fast, if it grows, it is going to grow in your body also very fast. That's all is coming antigenic structure of bacteria. So when we are going to talk about how disease can be caused, we need to say the port of entry. That is in review question. You need to remember it for final exam. Review. That means port of entry. Okay. Port of entry, microorganism, how enters. I don't want to mention again. Now we are coming next is going to be portal of exit. How microorganism enter, how it is going to be eliminated from your body. Okay, by vaccination process, when you are withstanding the disease, and then those microorganisms cannot cause a disease, and then can be eliminated from your body or being neutralized. You see, if you have antibody already, it is going to neutralize it in your body system. If there is no antibody, then pathologic process goes on. So for this reason, the microorganism causing a disease are coming in the port of entry and then eliminate by port of exit. That we are going to understand, and then we discussed already. Parasitism and pathogenicity, we discussed. The microorganisms are not parasite, all are not parasite. There are certain microorganisms can live without us also. Outside our body system, they can live. For example, anthrax and then tuberculosis, they can stay about 80 to 100 years in the soil, out of our host system, you see. But we are generally saying because they are going to cause a disease, and then they are parasite, you see. Parasite, why? Because they want something from us. If they are going to be independent, why then 80 years? Why 100 years? Why not 200? Why not 1,000 years? Why not million years? You see, even though there is a gap exists, it makes them a parasite on us. Okay, now those parasites are having pathogenicity character, which is going to be a virulence factor, a disease causing factor. Really, it is beauty theory, which you need to know this one. If you are becoming a nurse or a doctor or PA, these are very important topics, which we say pathogenicity. In nursing, you are going to have about very big book, maybe about 600, 700 page book, which you are going to study pathogenicity. Pathology, generally, you are going to study. In pathology, you are going to focus more in bacterial area. So know it. In pathogenicity, a causing character in microorganism are virulence factor. Those virulence factor are enzymes. You see, enzymes. Those enzymes we are comparing in innate immune system, which one is more pathogenic comparing or more destroying comparing our cell system, which we call white blood cells. So that is very important to know virulence factors. You see, virulence factor is antigenic character of microorganism, and then disease causing factor in microorganism, especially on bacteria. Okay, now, so when we come, we need to understand the virulence factors. Those we call them enzymes. You know, hey, enzymes, when we study in anatomy or physiology, they are catalytic, catalyzer. They are going to make it an action and then return back to the normal condition. Very interesting. What about in bacteria? Yes, they can cause a disease and then neutralize it, or they are going to keep it there until that cell is destroyed. So we call them enzymes. Enzymes are virulence factor of the bacteria. The virulence factor of the bacteria are antigens. You see, antigens, pathogenic character of microorganisms are enzymes. Those enzymes are virulence factors, you see. So for that reason, we are going to mention certain of them. For example, you have studied this one. Remember in the questions, also repeat questions. Staphylococcus, streptococcus. You see, those ones are having their enzyme, and then their end is going to be ASE. ASE are enzymes. You see, halonidase enzymes. Mostly, if they are coming with ASE, they are enzymes. In bacteria, they are virulence factors. Well, there are certain exceptional exist. Hemolysin with blood, leukocidin with white blood cells also exist. Here now, we have been focusing in lecture, we have been touching also in laboratory when we were discussing about unknown bacterial finding. What we have done. Okay, look now, very interesting thing. How the lecture part is joining the lab part. For example, staphylococcus is having staphylokinase, and then we call the coagulase character. Okay, this microorganism comparing to streptococcus, which is having enzyme streptokinase, those staphylococcus can live in a salty water. They can grow. So if you are having a media which is having salt, then staphylococcus is going to grow. Streptococcus, it will not. So streptokinase of that streptococcus is weaker one. You see, weaker one. It cannot produce its own enzyme in a salty media or seawater. You see, so for this reason, we have been studying those ones with MSA, mannitol salt agar media. Okay, that is one. The other one, we use hydrogen peroxide also. Hydrogen peroxide, when you use staphylococcus positive for hydrogen peroxide, and then staphylococcus negative with not forming foam. That is negative for hydrogen peroxide reaction. You see, there are so many ways which you are going to find in the future how much the bacteria are, how many enzymes in them. You are going to find by this way how to identify one organism. Very interesting, really. When you are going to work in laboratory, when you are doing complete those serological reactions, antigen, antibody, you do it. And then when you are doing a very complex reactions like enzyme link and absorband, say that we call it ELISA, complement fixation, immunoelectrophoresis, or immunoblotting techniques, when you do those ones, it is very interesting, really, very interesting. This is a science that deals very related to our future life, how we are going to be fine or bad condition, if we are going to be infected or not, we are in a healthy condition or in pathologic process we go. So for this reason, enzymes are very important. So that is the end on disease and infection, or relationship of microorganism, and then epidemiology. Epidemiology, we don't touch it because we discussed already. When we say outbreak, when we say endemic, when we say epidemic, we know those ones, especially pandemic, we know it with COVID-19. You see, COVID-19 is increasing, and then the peak is coming in December and January. You need to be very careful. That we said already as microbiology point of view. The viruses, they like cold temperatures. They don't like hot temperatures. So they are going to multiply. And then influenza comes, and then influenza is primary one, and then COVID will be secondary one. So you are going, then this influenza make its mechanism defense lower, then COVID will get you. So for this reason, precaution, please. Those are very important topic on disease and infection. Oh, microbe relationship with epidemiology on chapter 20. That's a good one. If you know that part, it's enough, really. Okay, now, when we are coming, we need to understand certain things here now. On chapter 21. On 11th edition, it says, resistance and the immune system innate immunity. This is very interesting topic, really. You like it. Very interesting. How Mama gave us, we will give a credit for Mama on this topic. Really. Mama, you see. Now, we are very interested how Mama take us those 280 days, and then after that, after we born, also after six months earlier after we are born, and then after that, how she takes care of us Mama is mama always. I'm telling you. Here, innate immunity is just calling our mamas and then our sisters today who are here today taking this class, and then you are tomorrow's mom. This is very important for you. When your children running to you, and then when the children in a war field are the soldiers, and then they say mama, mama, that is a good word, really. Mama is very important. Mama, you see, mama, even we don't have anything, mama is around, it is enough for us, really. Really, I am not very closer to mama, like I am very closer to my dad, but the memories mama is higher than my dad, even though I'm not very closer to mom. You see, look now here, mamas are, they pass us everything, not only their genetic information, not their body, not those 37 chromosomes. Dad will not give you, only you are getting those ones from mitochondria, and then mama is giving you that kind of gene, not dad. You see, we are saying haploid 23, 23, but mama is giving extra also 37 genes to you when you are coming to this environment. Mama is very important in your life. Look now here. So innate immunity, because they are given by mama. Haha. Look at here. Very interesting thing is here. It makes me very stimulated on I'm talking on this topic, really. Here now, just my mom passed away. I am when I'm thinking she is alive. Well, I'm talking about mama, about innate immunity. Really. Look, I'm enjoying talking to you here now. Look, when we say resistance, in the word it says resistance and immune system. Resistance means resistant. You see, when we are saying resistance and immune system is a protection system. I am immune means I'm protected. Okay, now, how you are protected? Mama gave you. Which one? Innate immunity. Look now, mama gave us. That is mama's gift, innate immunity. Look now. Then when we are saying immunity, it is a state of defending microorganism or avoiding the infection. We call it immunity. The system is immune system. You see, this is immune system, which we have studied in physiology, in other subject. One of the 12 system in our body is immune system. You see, immune system, a protection system. You see, we are going very deep on that on chapter 22 and 23. On 22, we are going to focus acquired immune system. And then 23, we are going to study serology, because we have antigen entering and then give you serum. And then that serum, we are going to study by different antibodies, those 5 immunoglobulin groups. So for this reason, immune system, when we say it is a process or how our host system opposes the disease coming to our body system. So for this reason, look now here, when we are saying resistance and immune system, innate immunity, and then when we are coming on Thursday, you are going to say resistance and immune system, the acquired immune system. The acquired immune system. I'll come on that topic, really. You are going to like both topics very well, really. Now, here when we say, look now, when we come, we need to understand about antibodies, because these antibodies are very important. The blood itself is very important. You see, if you are bleeding, that is it is the first emergency. You see, bleeding, blood come out means your life is gone. So for this reason, when we are talking about immunity, we need to understand blood. This is whole blood, as you are going to see. Why we bring it on immune system? I'll give you a reason why. Look, very interesting thing is, this is a whole blood. This whole blood is having plasma and then formid elements. Those formid elements, you know them. Those are white blood cells, platelets, and red blood cells. So little non-liquid part are formid elements. The liquid part is plasma. The plasma contains many important organic and non-organic elements, and then you are going to have also protein like albumin, globulin, and then fibrinogen. Look, a very interesting thing is, now in a plasma, do you find those all? Yes. But in microbiology, instead of plasma, we are interested on serum. We call it serology, the topic. Why serum is our interest point? Okay, Let me give you an idea here now. In plasma, there are certain proteins at the time of antigen and then antibody connection, they are making cross reaction, and then they can give you false positive or false negative. So plasma, we don't use it in laboratory. We know plasma. Plasma is important when a person in a military or wounded in a car accident, somehow we need to transfuse plasma without typing a blood type. Only one time, you see, one time, you see. So when you are coming, our dogs, we can make it transfusion again and again without typing even in somehow. Look here, plasma is very important on transfusion. Why? Because plasma is having all the components, organic, non-organic, albumin, globulin, fibrinogen, all of them are here now. Where? In plasma. The difference is only platelet and then red blood cells and then white blood cells are not there. Okay, now, so do we have protein? Yes. If a person losing blood, in the first place, he is going to get proteins necessary, that the blood vessel system does not collapse and then we may not go to the shock system. Okay, that's very important. Now, here now, plasma in microbiology, we don't use it too much. But if you are going to centrifuge plasma or whole blood as it is, if you are going to centrifuge, you are going to get serum. Look now, serum by centrifugation, you get it about 2000 round for 5 minutes, 10 minutes, you'll get it. So on the surface, there is serum. At the bottom, formid elements. Very good. Now, in plasma, look now, there is a complement, very specific protein. At the time of antigen antibody, it gives you false positive or false negative reaction, you see. So for this reason, plasma, we don't apply it in laboratory. We apply serum. Those serum are containing, look now, that protein, which we have here, albumin, globulin, and then fibrinogen. Fibrinogen, you know it. These are fibrin making with platelets, and then it is clotting factor, anti-flow clotting factor in our body system. Okay, good. Now, when we are coming to understand albumin and globulin, especially globulin is going to change immunoglobulin, those 5 immunoglobulin group, that Y-shaped molecule, which we call it immunoglobulin. So when we are taking plasma or whole blood, centrifuge it, when we get on the surface is a serum, that serum is containing immunoglobulin. That is very important in microbiology. Any reactions you want to do, serum is important. That's why we keep it for long time. You see, we can keep it long time in minus 80 degrees centigrade nitrogen. We can keep it, and then we can use it when we want. You see, we can produce monoclonal antibody, which are going to be hybrid of cancer cells with that, and then we can produce mono, and then those monoclonal antibody, we are going to touch this acquired immune system. Anyhow, we will come on that. Those ones, we keep them for a long time. We are going to use for diagnostic value, and then secondly, we are going to treat people. For example, there is a person, for example, positive for COVID-19. You take the blood, centrifuge it, and then you are having in the serum immunoglobulin. You transfuse that immunoglobulin to a person who is old enough, maybe about 80s, 90s, and then he is weak on certain mechanism are weaker. So you want to give him if you suspect, and then that person can survive. By what? By antibody you got from your friend who is already positive but healed, and then antibody exists on that person. This is well organized and then well played in veterinary medicine, you see, in animal science. We use it, you see. But now, here, how we are going to use it, I don't have this much background on that area, how they are going to apply it. So for this reason, monoclonal antibodies are very important, really. That we will touch it on another topic. Now to finish it, now this area, this I bring it from anatomy. This is not in your book, really, but the white blood cells there are. So when I talk about this one, mentioning about globulin, and then what that changing immunoglobulin in the serum, and then that is very high molecular weight, which we are going to measure it by kilodalton. And that high molecular weight is very good to resist another infection, because one bacteria of Salmonella is going to resist Salmonella coming, but it cannot resist anthrax, not Listeria. It is specific antibody is rejecting its own, you see, or neutralizing its own. You see, if another bacteria, when you have antibody against Salmonella, then the other bacteria from Listeria will, or Escherichia coli, will infect you. You see, that is specificity of that bacteria and antibody, you see. So for this reason, it is very important when we are talking in our body, we are having white blood cells. Those white blood cells are divided into two. They are granulated and then agranulated. Look now, these granulated ones, they have granules inside, even though they have nuclear area, nuclear molecules inside. So when we are coming here, look now, neutrophil, eosinophil, and then basophil, they are group of phil. They are. I will discuss that one more. And then these are monocyte, the site group. They have nucleus inside, monocyte, but they don't have granules in them. That's why we call them agranulated. Granulated. No granule inside. So we will touch now here. Look now. Leukocytes, when we divide, granulated and then granulated. The granulated ones are neutrophils, eosinophils, and basophils. We study physiology and anatomy also. We are very familiar with this one. Here now, very interesting thing is neutrophils from 50 to, look now, 50 to 70% of our circulating white blood cells are on the surface of our body. They are neutrophils. When the microorganism is passing the barrier system, the skin, the first ones which are going to capture those microorganisms are neutrophils. They are going to oppose, you see. So before it goes any further phagocytosis, neutrophils are going to take the early phagocytosis process. So we call them neutrophils. So look now, a very interesting thing which we need to grasp it. When we say granulated or granulocytic white blood cells, they are having the phil group. Phil, look now, neutrophil, phil, eosinophil, phil, and then basophil, phil. Phil means like. Mom likes her children, and then husband like his wife. Phil, we call filio in a Greek word, filio, love. But there is another one, we said agape, agape love. Agape love is more than the filio, filio, filio. I don't know, many husbands can offer their life for their wives. If they are offering, that is agape life, agape love, you see, really. Even the husband is very bad, mean. The lady give him a good love, even he is mean, then that is agape love. Otherwise, you go your own way, I will go my own way. That is filio. When it is necessary, we have love. We like each other, but the love is not fundamental, you see. So those kind of words exist. Now I'm going to bring you here. Now when we say granulated, that means they like neutrophils, they like eosinophils, and then they like to produce basophil. Which ones? Those phagocytic cells, you see. So that is one thing which we are going to focus. And then when we are coming, granulated, means opposite. So they don't have granules, it means. So these are the site group. Look now, site means cell. Mono, one, you see, monocyte. Site means a cell. Lymphocyte, site is a cell, you see. These two of them are very important in mechanism of defense. In early stage, these all came by mama. Mama gave us, you see, mama's product. You see, these are monocytes. And then what they do, I will give you that information. For example, there are certain bacteria like Listeria. Listeria causes monocytosis, means the production of monocytes. You see, that is inflammatory type of cells in Listeria monocytogenes. And then it has virulence factor we call listrolizine. Listrolizine is a virulence factor. So it creates different monocytes. It's own product of monocytes. You see. Now lymphocytes, when we say lymph cells are producing the size, you see, that we are going to focus when we say lymphocytes, lymphatic system, one of the three circulatory system in our body. You know it, lymphatic system, pulmonary blood circulation and then systemic blood circulation, or pulmonary blood circulation and systemic blood circulation are joined with the lymphatic system. So where the production of lymphocytes, now it is coming to thymus. Thymus is one of lymphoid organ which is producing lymphocytes. These lymphocytes are producing natural killer cells, and then B cells, B lymphocytes, and then T lymphocytes. Look, very interesting thing here now. What we are going to mention on this one. Look now. This is very important in microbiology, lymphocytes. You like it. When you are coming further studies, you will remember this one. Really, it's a very deep science. Only on the lymphocytes, you can talk maybe about 20 page on the lymphocytes. You see how cytokines are going to work in lymphocyte system. It's a very duplicated, and then it is very big industry to talk on that topic. But we are coming, make it in a short way. Look now, when we say lymphocytes, you see all those sites, we call them, they began, you see, even red blood cells, when we start, they come from the bone marrow. Red blood cells, red bone marrow parts, which arrive and then develop in different sites. Especially if you are going to take it now, look, bone marrow, you see, bone marrow is producing red blood cells. Red blood cells, when they are coming to thyroid gland, and then with a thyroxine, and then they are going to change that. Look now, thyroxine, those ones are going to change it to that calcium production. That calcium production is going to make you vitamin D. Look now, very far away in physiology. When we are coming to develop in thymus, they originated from bone marrow. Look now. In bone marrow, you know, there are yellow marrow exists, and then red marrow exists. There's red marrow, red blood cells, and then yellow marrow, they are producing lipidic structure fats, and then there are another which are going to produce lymphocytes. Those lymphocytes, when they come to the thymus, thymus is which is located at your sternum between the two nipples of left and right in the center. These are thymus, we call them. Those thymuses are going to produce natural killer cells, B lymphocytes, and then T lymphocytes in the form of lymphocytes. Look, very interesting thing here now. This thymus, at the age of 25 and 30, it is going to disappear from your life. It is not going to produce no more natural killer cells, B lymphocytes, or T lymphocytes. Who is going to take over? Aha. At the age of 25 and 30, according to the genetic background of you, long life, short life, depending on that, they are going to atrophy at age of 25 and 30. Then spleen and lymph nodes are taking over. Look now here. When we are coming older, we said our hormones finished. Aha, thymus is atrophied. Now we are going to come older and older. In a theory says, when you are born when you are the first time coming out of a mama, you are coming older. The science says you are coming older. So when you are coming older means you are growing until you reach certain years, about 80 years. When you are coming 80 years, 50% of your body is going to reduce. You are going to be atrophied. But like Thomas, at the age of 25, 30, atrophied. Aha, look now. If this B lymphocyte and then T lymphocyte, as a natural way, which are going to take care of you, are going to be atrophied. So you are left without B and T lymphocyte, strong ones. But there are, you see, the spleen and then the lymph nodes are going to take over. You see, that's why when you are even young, at the age of 20, when you have some kind of infection, the lymph nodes increase. Why they? Because they are having a lymph. That lymph is accumulating the foreign bodies, the antigens. Those antigens, the foreign body, even with certain virulence factor, must be neutralized in the lymphatic system, in the lymph fluid. So lymph node fluid that neutralize it and then dissolve it. After dissolving it, send it to the vein system. The exceptional is pulmonary vein only, which is going to carry only oxygenated blood. The other superior, inferior vena cava, whatsoever you can say, they are going to receive those artifacts from lymphatic system. Look now. So lymphatic system is a slave for superior and inferior vena cava line, pipe, you see. Look, very interesting thing, which we are going to understand. So for this reason, when those T lymphocyte being atrophied, and then these B cells, T lymphocytes, natural killer cells are not going to be produced in the industry of thymus, then they are going to spleen and lymph node. Now, spleen is not normally at the age of 25 to 30, it is going to accumulate dead cells. Yeah, it doesn't produce in the beginning B lymphocytes and T lymphocytes. No, it is just accumulate the dead cell until they are eliminated from our body. Look now, it is very fragile organ in our body, lung and spleen. You see, it accumulates. It is a depot center for dead cells and then dead bacterial or viral or parasitic cells. So that is going to take over after 25 to 30 years being atrophied that thymus. Very interesting. Look now here. Very interesting thing which you need to understand is now natural killer cells are very important in your body system, because when your body having, for example, red blood cells, erythrocytes, are going to live 120 to 140 days. Their life span is that. When they are coming 120, 121, 30, 130, they are going to lose their own viscosity. So they are coming very fragile. At this time, natural killer cells, they say, come to me. I will eat you up. Natural killer cells consume them. If they don't consume them, they are going to eliminate from the body as a waste product. Look at how natural killers are. And then the other thing is also, these natural killer cells are going to kill viral origin cells or virus infected cells in our body, or any abnormal cells in our body are going to be removed by natural killer cells. They are cleaners of our body, natural killer cells. Look how they are very important. Natural killer. Cancer cell, if you are having chemotherapy whatsoever you are taking, they are the ones who are cleaning up your body system. You see, natural killer cells. Very interesting. Old cells out, dead cells out, cancer cells out. You see? So here, natural killer cells. These are given by whom? By mama. You see, mama gave us. Okay, now, when we come to B lymphocytes and then T lymphocytes, look now, B lymphocytes are cell-mediated immune system. Cell-mediated immune system means one cell is protecting another cell, it means. Do they produce antibodies, those immunoglobulin group? No. Why? Because they are acting from cell to cell. Okay, lymphocytes, natural killer cells, eat, and then they form antibody? No. Okay, now, macrophage, in the process of phagocytosis, kill the product and then eliminate from the body. Are they going to form antibodies? No, because it is cell-to-cell action, and then they don't produce antibodies. We call these ones T lymphocytes. Look now, isn't it very interesting? T lymphocytes. So they don't produce antibodies. And then B lymphocytes, they produce antibodies. How do they produce antibodies? Just immunoglobulin, any antigen which is entering from your surface of the body or from cells, extracellular compartment, when it is penetrating to the blood vessels, and then in blood, it is going to be recognized as a foreign body. Being as a foreign body, it is going to recognize certain molecular weight molecule, which we call immunoglobulins. Look now. So antigen must be recognized. Antigen must be recognized in your bloodstream. So for this reason, it forms antibodies. Okay, now here, what are we going to understand in this process? Look now, this is granulated cells. We call it site group. Here, one thing which we need to understand, macrophage, phagocytic cells are closer to grasp the microorganism. That is, mama gave us that responsibility. So this macrophage, when they are very closer to grasp that bacteria is more stronger virulence factor than your macrophage. Isn't it very interesting? Look now. Our cells are very fragile. Why they are very fragile? Our cells, they don't have cell wall. They have only membrane. Bacteria, they have cell wall, except Mycoplasma group. They have cell wall. In their cell wall, they are having virulence factor, toxic structures. But our normal cell, they are not having this kind of structure. So they are weaker. Because they are weaker, this microorganism, for example, let's say anthrax. Anthrax attack our macrophage, and then macrophage says, oh, I got you, and then go around, and then like a amoeba is going to grasp it and then make the bacteria inside the center of its body. Aha, now bacteria says, I'll get you now. I am in the center. I will dissolve all your particles, your molecules, your cytoplasmic part. Until I go to the nucleus, I will destroy you. Yes, it will do it, you see. You know, all the cells in our body system, except the red blood cells, all of them are having nucleus. If the nucleus is distorted or damaged, the cell cannot survive. Okay, it will go to the center, it can damage the nucleus, and then occupy the cell. Okay, when it is occupied like this, that macrophage is being engulfed, no, being destroyed by the bacteria, by bacteria virulence factor, by bacterial enzyme, by bacteria toxin, which we can call if it is endotoxin or exotoxin. If it is gram-negative bacteria, it is endotoxin. If gram-positive, exotoxin. Those exotoxins, which you are going to find in anthrax, PX01, PX02 toxins, those ones are very strong, and then they are going to kill the macrophage. Then macrophage, when it is going to die, it passes its own information to which one? To helper cells. Helper cells, help me, I'm going to die, help. Okay, helper cells are not going to take any action. So what they do, very interesting thing is, these helper cells, they are going to look cytotoxic cells. These are soldiers with gun in our body. Soldiers with gun. Killer cells, nothing. They have only mouths, talk. They say, hey, help. That is helper cells. So macrophage will be helped by the calling of helper cells, and then cytotoxic cell will come. This cytotoxic cell, you see, this is which we are going to talk about cell-mediated immune system, cell-to-cell action. So T lymphocytes we mean. So this cytotoxic cell, they have their own toxin, and then they come and then they destroy the bacteria. By chance, they destroy the bacteria and fractionate the host cells also. The host tissue, the host cell, they destroy at the same time. That is why pus is going to be formed. Pus. Debris of the cell, debris of the bacteria, debris of red blood cells, inflammatory cells there. Those all joined together, they are making pus, you see. Pus is a product of war field with T lymphocyte system, cell-to-cell system, and then when they are fighting, some of them die, some of them are releasing their own toxin and neutralizing it. Okay, now, look now. We have macrophage and then helper cell. From the helper cell, we are going to have now cytotoxic cell. Cytotoxic cell make a debris and then make a pus. When it is making a pus, then there are suppressor cells. They are in a fourth stage now. Look, you see, we are saying macrophage, helper cells, cytotoxic cells, and suppressor cells. These suppressor cells say these T lymphocytes, this the one which cytotoxic cell take an action, and then they say, we took an action now. Hey, it is like military general. It says you kill them, you fractionate them, you make a pus already, so stop it there. Okay, now this cytotoxic cell obeys and then leave the next activity for suppressor cells. Suppressor cell neutralize it, and then those cell debris stay in that site, but little bacterial antigens, they are stronger, and then they are going to cause inflammatory process in the site. Inflammatory process. Through that inflammatory process, the blood vessels are increasing their porosity. They are going to improve their holes, and then the pores are going to increase in blood vessels. So these antigens are penetrating to the bloodstream. When they are penetrating to the bloodstream, they are going to recognize, they are going to make red blood cells. Around red blood cells, now they are going to make antigen antibody reactions or recognition. If there is no antigen antibody recognition, the molecules are non-molecules. They are not haptens, no low molecular weight antigens. They are higher molecular weight antigens. Mostly we are saying higher molecular weight antigens are any bacterial antigen which is going to be greater than 68 kilodalton, we call 68 kilodalton. So 68 kilodalton proteins are above, they are immunogenic. So they are going to be recognized in a blood, and then they are going to form antibody. Aha, now look now. So up to the bloodstream, anything from macrophage up to suppressor cell, we call it cell-mediated immune system. Very interesting. And then, look now, in a bloodstream, because this is going to cause form antibodies, we call it B lymphocyte. And then we call it humoral immune system. Humoral, when we say it is a blood now, it is in the blood, they are forming B lymphocytes. They are going to form what? And those immunoglobulin group, the 5 immunoglobulin groups. Very interesting. Look, this is how agranulated cells are working in our body. We can't say so many things on this, but I will leave some part for acquired immune system. Okay, now, dendritic cells are found on the skin. And then these are innate immune system. Mama gave us the skin. If you are black, white, or yellow, that is given by mama. Okay, now, when we are coming whitish, we are having more keratin and then less melanin. Melanin means the melanocytes are producing a small amount of melanin among the white people, white skin people, and then we are having melanin high concentration, which we are having dark skin, but we are having melanin also. As whites are having melanocytes, are a small number, they produce a small number of melanin, and then we are producing also, blacks are producing also high concentration of melanin, and then a small number or a small concentration of keratin. That's why dark skinic, brown skinic, something, you see. So for this reason, if that is, the skin is black, white, yellow, whatsoever, the mechanism defense is going to be taken care by neutrophils. You see, in the beginning, neutrophils. If there is bleaching the skin system, it is coming to neutrophils. Neutrophils return it back, you see, or kill them at the site of the skin area, you see. So if the insect is going to bite you, or IV is getting you, you see, the IVs are having certain toxin we call urushiol. Urushiol is irritating part from IV. When you are going to touch some plants, they are having certain toxin we call urushiol. That urushiol is going, if you are melanin or keratin skinned, if it doesn't matter, it is going to irritate you. The same neutrophils are going to fight for you if you are have keratin or melanin exists. So for this, we are going to remember dendritic cells. They are located on your skin. Those are very important. Mama gave us the product of mama. Okay, now, when we are saying lymphatic system, we are having composed of cells and then tissues. We know those lymphatic system, we say natural killer cells, B lymphocytes, T lymphocytes are cells. Okay, now, what about the tissues? Okay, we are going to say tissues, lymph tissue, lymph node tissue. Spleen is also lymphoid organ. It is a tissue, you see. It is an organ, but made up of a tissue. So the tissue is made up of a cell. So more complex of the cell organization is called tissue. The compound structure of a tissue is going to cause an organ, you see. So those are what we need to know about lymphatic system. So when we say lymphatic system maintains and distributes lymphocytes. Aha, that is very important, you see. That is how we need to understand. So we are having primary lymphoid tissues, are the thymus and bone marrow. You see now, thymus is going to, look now, bone marrow is going to produce certain cells and then develop in the thymus. Okay, thymus now is going to stay up to 25 and 30 years. That is primary one, look. Now, primary. And then that goes And then we are coming secondary lymphoid tissues. Which one? Spleen and lymph node. That's why I say that if the thymus is atrophied, now we are under the control of spleen and lymph nodes. Isn't it very interesting? You see. Now the spleen a depot for dead cells, and now it is going to produce lymphocytes. Lymph nodes are producing lymphocytes also after disappearing of thymus. Look now, that is how we are saying process of phagocytosis. Very interesting. Look now, we are coming to the main topic, which we call innate immunity and then acquired immunity. Look, very interesting thing is, if you have very good background, you may understand very good this topic really. Look, very interesting thing is, so when we say innate immunity, mama's immunity, we call it birth immunity. Mama gave us. Okay, now we are going to call them non-specific immunity also. Why non-specific immunity? Because mama gave us from anthrax, for salmonella, for listeria, any vaccine she took, she has an antibody. That antibody she gave us. That's why it is not specific. It is a collective innate immunity. You see, from common pathogens, there are vaccine produced. That vaccine, mama is vaccinated, and then she has antibodies. Look now, those antibodies, if she is vaccinated, 6 bacterial origin, 6 of them you are getting. When you are born, there is no problem. Even after you are born, 6 months, mama is taking over. Mama's blood is taking over. Mama's antibody is going to take over. Really. There is you enjoy mama, calling mama's name here. It's very interesting here now, really. So we call it innate immune system, mama's immunity, birth immunity we call it, non-specific immunity we call it, non-specific immunity. Okay, now, when we are genetically encoded from mama already, so it is common pathogenic features it may have, foreign substances, or mama has it, and then those antibodies she has it, and then cytokine, these are the cell production system which she has it, she is giving us, so that it duplicate the lymphocytes. The lymphocytes are producing so many of them. So here now we are saying innate immunity. When we are going to talk Thursday acquired immune system, it is acquired means artificial immune system. 1. You can say specific immune system. 2. We can call it adaptive immune system. Look now, adaptive immune system. Why we are saying adaptive? For example, you don't have a child, you adopt a baby, somebody gives you, you adapt it, you didn't give birth for it. So adapted, adaptive immunity. From where are you getting these antibodies? Because foreign bodies are being introduced to your body in the form of antigens, okay, through vaccination. 1. And then the other time, while you are eating cheese, you are eating certain fruits, you are eating certain foods, and then you didn't wash your hands, and then when you are eating some certain small number non-disease causing dose entering to your body, and then those ones are forming antibody, but they are weaker antibodies. Still you have antibody, you see now, by vaccination. 1. Secondly, if you are infected one time with microorganism, take antibiotic and then treat it, you have antibody. Okay. Thirdly, unknowingly, you are going to take certain food products, and then you are going to have some kind of, for example, staphylococcus. Within 4 hours after eating, you have vomit, nausea, whatsoever, and then your stomach is bubbling whatsoever. So they are producing their own toxin. Look now, staphylokinase. You see, that is an enzyme, and then that is the enzyme. If it is not large enough, and then you take antibiotic early, then you are going to block it, but you may have certain antibody, weaker antibodies. Okay, so you are having antibody. Look now, weak antibodies you may have. Some of them is strong antibody. A strong antibody you are going to have because the molecular weight of antigenic structure, the molecule, the antigenic structure having higher kilodalton, then you are going to recognize antibody. That antibody is going to stay maybe 1 year or more, protecting you. If there are low molecular weight antigen introduced into your body, and then through vaccination whatsoever, they are going to stay for a short time, maybe 6 months. Anthrax, for example, 6 months, 8 months. But when I produce in for animals, it is 10 months. or 1 year or up to maximum. And then we repeat each year vaccination. So for this reason, we are introducing antigen to produce antibody that we are going to say acquired immune system. We are going to take from dead cell, dead bacterial cell, or weakened bacterial cell, or from the DNA of the bacteria, or RNA of bacteria, or nucleoid material of the bacteria, or the toxic, the capsular antigen of the bacteria. We take it and then introduce to you. How to introduce it, what it include, we will touch on Thursday. We don't touch so many ingredients to mention about that one. So here it is very interesting. So acquired immune system, we are going to touch on Thursday. Today on innate immune system. What are we going to now on innate immune system? Look now here. We have a physical barrier system exists, biological barrier system exists, chemical barrier system exists. Mainly we have three barrier system exist. Look now. So in innate immune response, you see, we are saying physical, chemical, or microbiological barrier. We are going to say acidity also. Acidity and cell also. Cell to cell. How they are going to work, we will see now. Physical barrier is going to be the skin. Skin protect you from the outside. Yes, it shield you. Like you are inside the car part is going to cover you. You see, it is a skin which protects the interior part of our body. You see, blood vessels and then organs are covered by skin. So it's good. That we call skin is physical barrier. Insect bite you, protect you. Mosquito, it's a fly. The fly, the tick, when they come, if the skin is very strong, somehow it protects you. If it is strong, but if it's weaker, it will penetrate inside that pathogenic microorganism. So mucous membrane, yes, from mouth up to your anus, there is mucous membrane exists. Especially the mucous membrane, very important is in respiratory organ, from nasopharynx area up to bifurcation of your lung. Okay, bifurcation of bronchi, you see, which is going to enter to the lung. So from that, from your mouth area up to bifurcation of bronchi, they are having so many mucus producing cells. Look now, here this mucus is under very, very tiny cells, very tiny cells. Tiny cells are attached to the mucous membrane area. We call it the outer membrane. They are going to cover outer membrane. So this mucus is going to be produced if you are going to be irritated. You are going to eat maybe hot pepper, jalapenos you eat. Okay, maybe mucus is coming. Okay, sometimes you have very tasty food and then you didn't start yet, but you are gorging it and then you are going to, you see, submandibular, sublingual, and then the parotid glands are producing saliva, spicy food. They are going to cold and then your oral cavity is producing already saliva. Even the food is not in your mouth. Aha, that is mucous membrane. When you are respiratory organ, you are going down, they are cilia. Cilia, under cilia, there is a small amount of mucus droplets exist, which are keeping humidity in that membrane area. Okay, now, if you are having influenza or some kind of cold, that mucus is going to coagulate and then go out. And then you spit it out. One. Secondly, if you are respiring in dusty area or certain kind of smell irritating chemicals enter to your throat, and then those mucous membrane are accumulating around the cilia, and then you cough. That means the caplets are accumulating on the cilia, and then you are going to spit out. You see, that mucous membrane is very important. And then the mucus which is produced on those mucous membrane is very important. That we call it physical barrier system. Look, very interesting how we are. Now we are coming to chemical barriers. Lactobacillus, our sisters. Around vaginal area, this lactobacillus is making fresh. Urine is coming, leftover, fresh. And then when you are having menstruation, in 28 days, coming around, and then it refreshes you until the menstruation stops. These are going to work a lot, you see. So refresh you see, refreshing you, neutralizing the pH, you see. So lactobacillus, the pH, the bloody area, whatsoever the blood which is coming, almost pH about 7.3 and 4. Okay, when they are lactobacillus, they are acidic, and then they are going to neutralize it and then dismiss that thing artifact out from your body system. You see how it helps. You see, lactobacillus. You see, it's very interesting. This lactobacillus we are using for yogurt and cheese making. You see, cheese, yogurt, we make it. They are not dangerous, but they are dangerous when we are doing sex at the time of menstruation, and then our organ is penetrating around the cervix, and then pass it through the cervix, and then pass certain foreign bodies from lactobacillus itself, from the outside vaginal area to inside to uterus. Then you are going to be infected, and then you are going to give foul smell, and then no one is going to be closer to you. So for this reason, very interesting to keep up your own health condition now. Lactobacillus is very important. Mama gave us that one. You see, lactobacillus. We have it, mamas. The low pH, it is your stomach. The stomach is around having a pH 2. Look now. Hydrochloric acid pH. Look, hydrochloric acid 2 it contains in your stomach. Look, it's very interesting. Around the cardiac area in the fundus, the acidity is very high. The food which you are going to swallow are going to be broken there, you see. At the base of your stomach, around pylorus area, it is going to be alkaline, you see, alkaline. So when it is alkaline, it is not going to break this much, you see. Then the food which is going to pass that area, look now, acidic area, the cardiac sphincter area and fundus area, and then come to the passing on the road to the bottom of the stomach, J shape. At the bottom, it is going to have alkaline. So alkaline is coming from where? From the spleen, and then from the liver, especially bile is injecting it, alkaline. And then it is neutralizing. The neutralization product in our stomach is giving, because of that, it is for pH, it is going to give you salt and water. Look now, that is combination of HCl plus sodium hydroxide is giving you sodium chloride plus water. Look now, the product, and then neutralized. That's why when you are not eating from the morning, maybe you rush and then you eat only one banana, and then daytime you didn't eat, and then you come to my class, and then your stomach is going to give you a sound. It says, I'm acidic, I want to neutralize, give me something, it says. You see, so you need to neutralize it. Otherwise, you are having a stomach ulcer or duodenal ulcer, you see. So low pH is very important in somehow. Why? To inhibit the bacterial growth in the stomach. Defensins are certain proteins, you see. These are antimicrobial peptides. They stay in our stomach. Look at a very interesting thing is, these defenses are very important. Mama gave us stay in our stomach also. These defensins are defending you that your stomach, when it doesn't get enough fiber, they are going to make it soft. The stool whatsoever it coming, you see now. So defenses are very important, and then mostly they are working with fibers, you see. You don't have more fiber, then you are constipating. Aha, defensin, the growth of defensin or the balance of defensin you are messing up. Very interesting. For example, you are taking some kind of, you are having certain diarrhea. After diarrhea, you have constipation. Why? The diarrhea is removing defensin from your stomach. That's why you have, after diarrhea, constipation. So you need to get fiber. Fiber neutralize it. You see? So defenses are very important. Lysosomes. Yeah, you know it. These lysosomes are having, for example, tears, sweat, saliva, those 3 glands which we use, submandibular, sublingual, parotid gland, are producing saliva. That saliva is going to work with amylase. Amylase is going to be in saliva. That saliva is going to digest carbohydrates. If the food is not early digested in the stomach, it doesn't go. You see, those circular and the longitudinal muscle of your esophagus, they say, no, we don't. It is not smooth enough. We don't. Even passing those muscles and then reach to the cardiac sphincter, and the cardiac sphincter says, no, vomit it. I don't want to accept it. You vomit back, you see. So for this reason, even the food which you are eating, when you chew it up by saliva, digested it, and then take it on your hand and then smell it, it stinks like a shit, you see. Saliva is producing this amylase. Amylase is not a good smell, really. You see, do you want to sit around someone who is vomiting? There is amylase there. You see, with a vomit it comes. You see, so for this reason, those are killing bacteria also. Saliva, they are mostly Lees gram-positive bacteria. The sweat also. The sweat is having certain bacterial killing characters. Tears, yes, tears. You know, in veterinary medicine, what we do if a person is having conjunctivitis or an animal having conjunctivitis, we take a blood. If we don't have any antibiotic, we take the blood, centrifuge it. From that centrifuge serum, we will take a droplets and then 2 to 3 drops 2 times a day or 3 times a day around the eye. We clean up conjunctivitis. That means it killed the bacteria. You see, that is very interesting. Tears are having bactericidal character. You see, so it is very interesting. Now, when we say lysosomes, lysosomes are in another one. It has so many characters. We will touch this one in serology area again. Okay, cellular barriers. We touched already that one. The macrophage, you see, the macrophage, helper cells, and then T cells. How they are going to work with cell-mediated immune system, macrophage, helper cells, cytotoxic cells, up to suppressor cells. These are cell barrier system. You see, we touch those ones. Very good, really. Okay, now, how immune system works? A little bit longer. Please be patient here now.
Trillions of microbes ready to invade our bodies lurk in the air, the water, the foods we eat, and on the objects we touch. Nevertheless, most of us are healthy most of the time and unaware of the constant battle between body and microbe. Even when infections occur, we almost always fend them off quickly. Our usual state of good health is due to 3 lines of defense: external barriers that keep microbes out of the body, non-specific internal defenses that combat all invading microbes, and our immune system, which assaults specific microbes. The body's first defense against microbes are the skin and the mucous membranes of the digestive and respiratory tracts. The dry, dead cells filled with hard proteins that cover the outer surface of the skin prevent most microbes landing on the skin from obtaining needed water and nutrients, while acids and natural antibiotics secreted by the sweat and sebaceous glands actively inhibit the growth of bacteria and fungi on the skin. The membranes of the digestive and respiratory tracts are protected by mucus, which contains antibacterial enzymes that destroy the cell walls of bacteria and physically traps microbes that enter the body through the nose or mouth. Cilia on the membranes sweep up the mucus, microbes and all, until it is either coughed up, sneezed, or swallowed. Swallowed microbes enter the stomach, where they encounter a combination of extreme acidity and protein-digesting enzymes that kills many microbes. Farther along the digestive tract, bacteria harmless to humans secrete substances deadly to other invading bacteria or fungi. Though these defenses are good, the warm, moist mucous membranes are more vulnerable to invasion than the skin. Disease organisms that enter the body through the skin or mucous membranes run into 3 non-specific internal defenses: standing armies of phagocytic and natural killer cells, the inflammatory response, and fever. Monocytes and neutrophils are phagocytic white blood cells that travel through capillaries to wounds where bacteria have gained entry, then ooze out through narrow openings in the capillary walls. After leaving the capillaries, monocytes differentiate into macrophages, amoeba-like cells that engulf and ingest bacteria and other foreign particles. Neutrophils, the most numerous of white blood cells, like macrophages, also engulf foreign invaders such as bacteria and certain fungi. Both monocytes and neutrophils secrete molecules that attract other defensive cells to the invasion site. Natural killer cells are another class of white blood cells. They do not directly attack and engulf invading microbes, but rather identify and destroy body cells that have been invaded by viruses or that have become cancerous. Sensing molecular changes, natural killer cells bind to the compromised cell's cellular membrane and release proteins that pierce holes in it. Cytotoxic proteins then ensure the destruction of the abnormal cell by entering it and destroying its nucleus. Breaches of the skin or mucous membranes elicit an inflammatory response. Damaged cells release the chemical histamine into the wounded area. Histamine makes capillary walls leaky. Leaky capillaries cause fluid to seep from the capillaries into the tissues around the wound. The wound becomes red, swollen, and warm. Meanwhile, other chemicals released by injured cells initiate blood clotting that both blocks damaged blood vessels, preventing microbes from escaping into the bloodstream, and seals off the wound from the outside world, limiting the entry of more microbes. Still other chemicals, some released by wounded cells and others produced by microbial invaders, attract macrophages, neutrophils, and other phagocytic cells to the wound, where they engulf microbes, dirt, and tissue debris. The pus that collects around a wound consists largely of microbes, tissue debris, and living and dead white blood cells. If enough microbes survive the inflammatory response and infect larger areas of the body, a fever may be triggered. While severe fevers are dangerous, even fatal, average fevers of 38 or 39 degrees Celsius, 100 to 102 degrees Fahrenheit, are beneficial. In the brain, the hypothalamus contains temperature-sensing nerve cells that normally set the body's thermostat at about 37 degrees Celsius or 98.6 degrees Fahrenheit. However, certain white blood cells, in response to infection, release hormones called endogenous pyrogens that cause the hypothalamus to trigger behaviors that increase body temperature, shivering, increased fat metabolism, and a feeling of cold that causes a search for heat and warmth. The release of pyrogens also results in reduced iron concentrations in the blood, which, combined with the fever, slows the reproduction rate of many bacteria. Further, fever increases the activity of the phagocytic white blood cells that attack bacteria. Fever fights viral infections by increasing the production of the protein interferon, which is synthesized by certain body cells when they are invaded by viruses. Interferon released by these cells travels to other cells and increases their resistance to the viral attack. While often effective, these non-specific defenses are not impregnable. When they fail to do the job, the body then mounts a highly specific immune response directed against the particular organism that has successfully invaded the body. More than 2,000 years ago, the Greek historian Thucydides recognized that occasionally someone contracts a disease, recovers, and never catches that particular disease again. The person becomes immune. With rare exceptions, however, immunity to one disease confers no protection against other diseases. Thus, the immune system attacks one type of microbe, overcomes it, and provides future protection against that microbe, but no others. This is why we refer to the immune response as a specific defense against invasion. The immune system consists of about 2 trillion specialized white blood cells called lymphocytes. Many are distributed throughout the body in the blood and lymph. Others are clustered in specific organs, particularly the thymus, lymph nodes, and spleen. The immune response results from the interactions among several types of lymphocytes and the molecules they produce. The immune response is provided chiefly by 2 types of lymphocytes, B cells and T cells. As with all white blood cells, B and T lymphocytes arise from cells in the bone marrow. Early in development, newly forming T cells migrate to the thymus, hence the name T cell, and differentiate. B cells differentiate in the bone marrow itself, hence the name B cell, and later migrate typically either to the spleen or lymph nodes. Immune responses produced by both B and T cells consist of 3 steps: recognizing invaders, launching an attack, and retaining a memory of the invader to ward off future infections. To understand how the immune system responds to invading microbes, 3 questions must be answered. How do immune cells recognize foreign molecules? How do they produce specific responses to so many different molecules? And how do they determine that a substance is foreign and not self, thereby avoiding destruction of their own body tissues? The key to the immune system's ability to attack invading microbes lies largely with proteins called antibodies and T-cell receptors. Antibodies are either attached to the surfaces of B cells or dissolved in the blood plasma, where they are called immunoglobulins, often abbreviated IG. T-cell receptors are only found attached to the surfaces of T cells. Antibodies are Y-shaped molecules composed of 4 peptide chains, 1 large, heavy chain, and 1 small, light chain on each side of the Y. Both heavy and light chains consist of a constant region that is similar in all antibodies of the same class and a variable region that differs among antibodies. The combination of light and heavy chains results in an antibody with 2 functional parts, the arms and the stem of the Y. The variable regions on the arms form highly specific binding sites for large molecules. Each binding site has a particular shape and electrical charge, so only a few, or perhaps only 1 type of molecule can fit in and bind to the site. In general, only large, complex molecules, such as proteins, polysaccharides, and glycoproteins, bind to antibodies. These molecules, or antigens, may either be attached to the surfaces of cells, the body's own or invading microbes, or dissolved in the blood or extracellular fluid, such as snake venom. As we will discuss shortly, the binding of antigen to antibody triggers the immune response. The stem of antibody molecules, which consists of part of the constant regions of the 2 heavy chains, determines the activity of an antibody. Though the constant regions in different antibodies are similar, they are not identical. For example, the heavy chain constant regions forming the stem of 1 type of antibody may attach the antibody to the plasma membrane of a cell. The constant regions of another type of antibody may bind to certain proteins in the blood, called complement, to promote the destruction of microbes.
Of all the immune system soldiers, natural killer cells are the most aggressive. They are lymphocytes with no immunological memory and are part of your innate immune system. Natural killer cells make up about 5 to 15% of the total circulating lymphocyte population. Natural killer cells are called natural killers because they do not need to recognize a specific antigen before releasing their toxins and destroying a viral infected cell or cancer cell. They target tumor cells and protect against a wide variety of infectious microbes. In several immunodeficiency diseases, including AIDS, natural killer cell function is abnormal, thus allowing the viruses to multiply inside of human cells. Natural killer cells kill on contact. The killer cell binds to its target, aims its weapons, and then delivers a lethal burst of toxins that produces holes in the target cell's membrane and creates events that destroy the cancer cell membrane and cleaves DNA into many pieces in a programmed cell death, that is, apoptosis manner. After releasing its lethal package of chemicals, the natural killer cell can detach from the cancer cell and kill many other circulating abnormal cells. Indeed, research has shown that most of the tumor cells that enter the circulation are destroyed during the first 24 hours, and only a few cells succeed in establishing themselves in distant organs from the primary tumor, which is called metastasis. Natural killer cells may also contribute to immunoregulation by secreting high levels of influential lymphokines. Therefore, research to develop natural products to stimulate the natural killer cell activity, especially in immune-suppressed patients undergoing chemotherapy for cancer, or in any viral disease such as AIDS or bird flu, where immune suppression occurs, is very important in the regulation of aspects of the immune system which affects our overall health. Finally, we come back to the beginning of our knowledge of the natural killer cell. Here lies a natural killer cell in a lawn of sheep red blood cells. These cells are perfect targets for the natural killer cell, possessing no MHC1 receptor. The wrath of natural killer cell is fully vented on the surrounding sheep red blood cells. The cytotoxins completely destroy the sheep red blood cells, leaving clear plaques around the natural killer cell. There is no apoptosis event, just direct cytotoxicity. The natural killer cell is one of the key soldiers in the fight against viral and cancer growth.
Antibodies are proteins that play an integral role in the complex system of specific immunity. They bind to and inactivate foreign proteins called antigens. Each type of antibody binds to one kind of antigen molecule. B cells are one of the two types of white blood cells that make antibodies. When a bacterial cell enters the bloodstream, proteins on its surface act as antigens and trigger response by the immune system. These antigens will bind to the unique B cells that have the corresponding antibodies on their surfaces. These B cells now divide. Some continue to divide, producing many plasma cells. Plasma cells secrete large quantities of antibodies into the bloodstream. This division of only the appropriate B cells is called clonal selection.
When we come about inflammation, we discussed, but I may give you some idea. So inflammation is microorganism entering to the tissue or to the cell and then making a war field. And then that war field is making a pus. At a time of inflammation, the blood vessels porosity is going to increase. And then certain are going on the extracellular compartment. You see, so here one thing which we need to know is when there is inflammation, most of the time we are going to observe the increase of temperature from 37 degree or 98.6 degree Fahrenheit up to 101 or 102 for adult person. You see, when it is increasing, it is a good sign if there is inflammatory process. It doesn't mean because of inflammation always temperature can increase because you are infected. That you need to understand it. Inflammation is not only the product of being infected. It can be inflammation in a tissue. When you are driving a car, some accident happened to your body system, temperature triggers out also. So for this reason, you need to understand there are certain people, always if there is inflammation, there is infection. It's not true. And then if there is inflammation, always temperature increase, it is not true also. That is depending how deep that inflammatory process is going on to cause a disease. For example, inflammation, acute case, in acute case, yes, temperature will go. What about if it is subacute or chronic case? Chronic case inflammation, it doesn't trigger temperature, you see. So for this reason, be out of a doubt saying if there is inflammation means always temperature may increase. It's not. So that this video will give you a good information also.
Inflammation is the body's protective response against infections or injuries. Inflammation mobilizes defensive cells to the site of injury, limits the spread of pathogens, eliminates them, and initiates tissue repair. Inflammation can occur in any organ, but is most common and also most easily observable in the skin and underlying tissues. Typical signs include redness, heat, swelling, and pain. Inflammation is an important defense mechanism, but it can be a double-edged sword when things go wrong. An autoimmune disease may result when inflammation targets and destroys the body's own cells. An acute inflammation that fails to stop after the original insult is cleared can become chronic and damaging to healthy tissues. Acute inflammation is initiated when tissue-resident immune cells, such as macrophages, encounter an inflammatory stimulus. This stimulus can be a pathogen, a toxin, or an injured host cell. Binding of the stimulus to its receptor on the immune cell triggers a signaling cascade that activates production of cytokines and other inflammatory mediators. Inflammatory chemicals dilate blood vessels, increasing blood flow and enhancing vessel permeability, allowing plasma fluid and more immune cells to seep through and accumulate in the inflamed tissue. This vasodilation is responsible for clinical signs of inflammation such as redness, heat, and swelling. The infiltration of blood components into the injured tissue occurs in 3 phases. The first phase is the exudation of plasma fluid containing various antimicrobial mediators, platelets, and blood clotting factors. These factors can destroy microbes and stop any bleeding that may have occurred. The second phase is the infiltration of neutrophils, the major phagocytes involved in first-line defense. Once activated by inflammatory mediators, endothelial cells of blood vessels become adhesive. They attach to neutrophils in blood flow, slowing them down before getting them to squeeze through the vessel wall. Chemical cues guide neutrophils to the battlefield, where they engulf bacteria and destroy them with enzymes or toxic peroxides. Neutrophils may also release highly reactive oxygen species in a phenomenon known as oxidative burst, which kills pathogens faster and more efficiently. The pathogen-laden neutrophils then die via apoptosis. In the third phase arrive monocytes. Monocytes differentiate into macrophages, which then remove pathogens, injured cells, and dying neutrophils by phagocytosis. Macrophages that have completed their mission are cleared from the tissue by the lymphatic system. Accumulation of fluid increases pressure on lymphatic capillaries, forcing open their one-way valves, facilitating lymphatic drainage. Lymph-containing debris-laden macrophages passes through a number of lymph nodes and is filtered clean before it returns to the bloodstream. Once the site is cleared from the original insult, immune cells stop producing pro-inflammatory chemicals and instead start producing anti-inflammatory mediators, which actively drive the termination of inflammation. Many of these anti-inflammatory molecules are lipids, some of which are synthesized from dietary omega-3 fatty acids. This step is essential in ensuring the favorable outcome of inflammation. Failure to resolve inflammation leads to development of chronic inflammation, which continuously deals damage to healthy tissues. Chronic inflammation is a known contributing factor to pathogenesis of a wide variety of conditions, including cardiovascular diseases, asthma, diabetes, arthritis, and even cancer.
Now, moderate fever benefit host defenses. How? Inhibiting rapid microbial growth, as you have seen, encouraging rapid tissue repair, and then heightening phagocytosis. If the temperature rises above 105 degrees Fahrenheit in adult, most metabolic inhibition can occur, and then death may appear also. So that will be a very interesting part which we said in our case about natural killer cells. We said already how these natural killer cells migrate to tonsil, lymph nodes, and spleen at the age of after 25 and 30 years. And then these natural killer cells, how they control cancer cells, virus infected cells also, that we mentioned before also. Interferon, this is one. And then this is the last one, how interferon, what do you understand about interferon? Interferon mostly applicable to trigger about viral infections. So if there is contamination by certain viral origin by viral products, and then you will be contaminated, and then to free you from that kind of toxin, we need to introduce interferon. We don't use antibiotics or any drugs. For example, they are saying Acrovar, Tirovar, Serovar, whatsoever they say. There are so many antimedin. There are drugs which we are using them against viruses. But in the joker is interferon. Interferon can be prepared in vivo or in vivo or in vitro. Means it can be out of the cell, on the cell culture, we can make it, or in laboratory in laboratory animals. So here you have one short video, which is going to take about 2 minutes, maybe less. Say this one.
As we saw, it fuses with the host cell and releases its genetic. The immune system has several defense mechanisms against viral infection. Here, a virus binds to its target cell. As we saw, it fuses with the host cell and releases its genetic material into the cytoplasm. When the foreign genetic material enters the cell and starts to synthesize viral products, the cell is stimulated to make alpha and beta interferons. These interferons can signal to neighboring cells to directly inhibit viral metabolism. They do this by binding to interferon receptors, which signal the synthesis of antiviral proteins. The antiviral proteins can switch the cell into a virus-resistant state if it should become infected. Interferon gamma, produced by the activated T cells, also induces synthesis of MHC class I molecules, which make the cell more readily recognized by cytotoxic T cells. When a virus infects the activated neighboring cell, the antiviral proteins detect foreign genetic material, becoming activated, and block viral replication by breaking down the mRNA and stopping protein synthesis. These proteins put the cell into stasis, which limits further replication of the virus and
Well, it is stop here now. Exactly, I said your activity begins at 6:45. Only 1 minute left. You see now. Let me mention something. I finished with this one really. Before I go to the next topic next week on Thursday, I'll give you some summary on this one. I'll give you some clue with this, and then we'll continue on acquired immune system. It is very beautiful. Don't miss it. Be on time, and then we will see. But you are good today. You are almost 40 students in the class. Only one student is missing according to this number. You don't need to write. You don't need to say anything. I have a system which I can capture your names. So after we finish, it is going to give me the list of the students. Thank you very much. And then let me mention something for you. We are the college is contributing or giving food for people who are in need. For example, for Thanksgiving whatsoever, November 19, they are giving food in Compton. And then November 25, Turkey also, they are giving on November 25. So you can take somebody from your family, if there are certain people who needs it, from neighbor, collect, just take with them, and then let them have. There are so many things they are going to give on that day, as we are doing every year. Okay, that is one. Secondly, last time I told you that there are only 5 students applied, and then 5 students got certain amount of money. Look now. I told you that for physiology and microbiology, morning and evening. I told you, if you are getting $25, if you get $50, if you get $1,000, you don't pay it back. Why don't you try? Now we are having about $100,000 now. When they are going to open it, I don't know. They are going to post it on the website, on Canva, in Compton website. Try to check those ones, please. You need to apply and then get some amount of money. This is given by someone who is freely donating to our college. So don't miss it. Why don't you try like those 5 students? Try it, If you are going to mention my name is necessary, I'll give you. If you are not taking class with me now, if you are taking physiology and another time on spring, if you are taking physiology with me, I have many students taking physiology, but I start with 34. I didn't add any student, 34. And I have 34 students. None of them drop. And physiology more easier than microbiology too. Really, I'm telling you. This is the first time in my life I make the exam very easy, especially for a student in microbiology. Microbiology is very hard, really. It's very hard because now we are on a stress factor, and then I didn't want to push you too much. So that's why it makes it easy. Really, for example, you are going to take a lecture now, and then activity must go. We don't have so many activity. We finished those activities, laboratory activities. So that's why I'm giving you activity that you accumulate points. Do it. Accumulate those points for you, you see. So don't miss it. This is innate immune system. It is easy topic which I discuss. You see, those innate immune system, you give a report. You can find so many materials on Wikipedia or Google around. You'll find them. And from your textbook, you'll find them. I don't need citation or whatsoever. You need to do that one and then post it, that one. It is very good. And then that laboratory report, please, if anybody who didn't buy the $32 ebook, then talk to someone, exchange with someone, get from someone information, and then on that copy you can write it and then submit it also. You are not obliged to buy it. If you have somebody has it, that book, ask them, let them send you in there. With that you fill it up and then send up to, I think, four of or 8. I don't remember the date. So try it, fill it up. Only you, I gave you 26 pages to fill it up. But finally, I want only 20. 20 or 24, I don't know. Those ones only you need to send. So for this reason, I make it easy for you, really. You see, physiology students are presenting 37 page. There are students who are taking physiology and also microbiology. And then those students who are taking physiology last time asked me, what about exams? Physiology, you are taking exam on 4, the first exam, and then final one on 8 or something like that. So I gave a very big gap. You see, that is a good way. And then when you are taking microbiology exam early, and then you have reviewed it. So that gap, you are going to prepare for yourself. So really, I think that one when you are taking classes. That's why students, they didn't drop. Even their students are communicating me to be registered on spring 2021 now. You see, so for this reason, really, I didn't make it hard. Try to get a good grade and then enjoy. Let's pass it and then enjoy, really. So that is all I have. If you are having any question, please post it on Canvas. Please don't email me. There are some students still emailing me. No, don't, please. Try to send me, because I see, I open it, my computer. On Canvas, I open it always. I go look coffee, do something, I'll come and then answer it. I'll go somewhere else. But the email, I don't open it every day. Every time I don't open it. Maybe morning I open, evening I open it. But the Canvas, I open it, I leave it always open. You see, if the question to be answered, I will have answered it there. You see, please email me on Canvas, please. That is one thing I will ask you. And then I wish you the best, and then finish that and then enjoy.